Oh boy. Well, thank you, Brother Ken. Good evening, brethren all. My name is Eric Giler-Tomala. I'll be presenting this evening as beautifully titled "The Gavel from the Gavel to the Galaxy." The idea of presenting a little bit of the ISS and the near future of space exploration. So, who am I? As some of you, these are some new faces that I see before me. I'm a graduate of Embry-Riddle, Prescott, right down the road up on Willow Creek. I was a past emergency manager with the Yavapai County Office of Emergency Management. I was the emergency planner there. I was the AV event technology supervisor with Embry-Riddle for a number of years, and also the past master of Aslan Lodge in 2018. Hence, you haven't seen my face around. Beyond that, 2019, I kind of skedaddled out of Prescott and moved down to Houston. Got a job technically with S&K Global Solutions, who is contracted under Boeing, who is contracted under NASA to be a payload interface requirements engineer for the International Space Station. A lot to say. So I originally started as that higher position. As I went along, they're like, hey, you're doing a good job. Let's push you up to be a lead stage engineer. So working with the payload requirements team on a flight-by-flight basis. Those are the resupply missions that go up to ISS. And I report up to NASA management on what's happening on this flight. This payload is doing good. This payload isn't, et cetera, et cetera. Going through that, apparently I did so well within the company of S&K Global Solutions that I became the deputy program manager of our contract, the BETS contract, then the Boeing Engineering Technical Support. So I interface a lot with our local president, Boeing management, NASA management, et cetera, along with my 42 direct reports working within Boeing, doing all kinds of support, sustaining for the ISS. And I also volunteer at Space Center Houston. So if you're ever down those parts, hit me up. My information is in Grandview, and we can get coordinated and we can take a tour of Space Center Houston. So ISS, this first little part is a little bit more about me. These are the increments or expedition patches or logos for each expedition. Ever since 1999, 2000, when we set up our first crew to ISS, they've been counting for however long that's been. When I started with increment, what was it, 62, 60. I forgot to put number 60 up here, but these are all the patches that I have. And I love to collect things. So I've been collecting all those patches, and this is what I have up on my, above my cubicle. So all the patches thus far, and hopefully more into the future, as well as each cargo resupply mission, CRS mission, the Crew Dragon, the Cargo Dragon, the NG flights, SpaceX flights, HTV, if you happen to hear those, Soyuz, each one gets a patch that they design. So I've been collecting all the patches of the ones that I've been there since I started with the program. So this adorns the corner of my cubicle, starting with HTV X8, which is our Japanese resupply, Soyuz MC-15, which is our Russian resupply and crew, and then NG, I can't read that one, NG, SpaceX, et cetera, et cetera. So all of those are kind of remind me of why I do this and continue doing requirements and interfacing with those. So moving on to what I'm here to talk about this evening. What is the ISS besides a big thing that floats in the sky? Technically, multinational, long-term, low Earth orbital laboratory focused on conducting scientific research in microgravity, advancing human space exploration for the future of Moon and now Mars missions, fostering international cooperation, serving as a lab for biology, physics, and medicine. So along with the ISS, it's supported, since it's international, it's supported by 5 space agencies and a total of 15 countries. The main one here in the US, of course, being NASA, Roscosmos, our Russian counterparts, serving in this. ESA is the European Space Agency, supported by the 11 member countries within ESA. And then JAXA, the Japanese Aerospace Exploration Agency, and CSA, the Canadian Space Agency. So those are our 5 agencies that help support, send up resources. There's a few modules up on ISS that are supported by these countries that have helped launch it, and we send up astronauts and cosmonauts from these countries. We primarily launch now from Baikonur in Kazakhstan. That's the Roscosmos base, and then Cape Canaveral in Florida. Those are our 2 launch sites that we launch to the ISS from Earth. So numbers. I know you guys like numbers. I'm not going to go too deep, but we're gonna dive down a little bit with some of this. So we launched our first module, the Russian Zvezda module. I believe I pronounced that correctly. on 20th of November, 1998. So Baikonur, you beat me to it. Those are the launch sites that we send up from Kazakhstan and Cape Canaveral, SLC-40 Kennedy, LC-39A, and LC-39B. Those are when we launch with the shuttle. This is when constructing the ISS. Nowadays, we do not launch off of those launch sites. I can't remember which ones, but those are specific to crew and cargo nowadays. The ISS, it's a multinational cooperation. So a number of Russians helped create that. When they designed Mir, they took a lot of designs from Mir space station and incorporated into the Russian segments of ISS. For the US segment, Boeing was one of the prime contractors in building the US lab and a few of the other modules. JAXA has their own module, and I don't know who built that one. And ESA has their own module, and I believe it is a corporation out of Italy that helped build the Columbus module. So the mass of ISS is roughly around 450,000 kilograms, 990,000 pounds for imperial units. It's about 109 meters, 350 feet, 358 feet, and about 73 meters, 239 feet. Numbers are numbers. It's hard to conceptualize how big that is. So this is in perception of a US football field, how big the ISS is. Primarily the crew only habitats this portion here in the middle. Everything else, the crust segment that goes across along the solars are not habitable, but during EVA's extravehicular activities, the crew will put on their suits, get out of one of the airlocks, and they will slowly climb all the way across to do activities outside. So more numbers, because we all love numbers and data and everything else. Perigee attitude. So this is the lowest point that ISS is orbiting around the Earth, about 413 kilometers, 256 miles. Apogee, the highest it orbits around the Earth, about 422 kilometers, 262 miles. Again, what does this mean? So the dot is where we are here in Prescott, Arizona. That is the distance high up that ISS would fly. So about the Four Corners region is, if you were to drive that straight line, that's how far ISS is above the Earth at any given time. The ISS is technically a low Earth orbiting vehicle. Very unlikely given how much, mind the pun, space there is. But it is very low likelihood, but NASA, along with the other agencies, do track where every satellite is, and everything larger than, I believe, 5 centimeters is tracked that is in orbit. So anything, and a satellite that may have burned up, any orbital debris, defunct satellites, it is and being tracked at all times. And if the ISS is going to be in an intersect path with one of those, they will adjust and do some maneuvers to get out of that path. So continuing on, good question. Orbital speed, how fast it's going, about 7 kilometers a second, more on the line of 8, about 5 miles per second is how fast it is going around the Earth. Orbital period, it goes around the Earth every 92.9 minutes. So an hour and a half, it has gone around the Earth. So again, kind of hard to believe. They see approximately 16 sunrises and sunsets every day. And since it has launched in 98, it has been 9,972 days that it has been continuously going around this Earth, and it's been occupied since November 2nd of 2000, so 9,259 to today. And it has been continuously occupied since that time frame. Decay. Because it is a low Earth orbit, atmosphere does affect it, so it does have a 2 kilometer per month decay. Just the small bit of atmosphere that it hits slows down, and it's slowly the gravity of Earth pulls it down. So about every month comes down about 2 kilometers, then it boosts back up, comes down, boosts back up. And that's what I have here. This is shown over a few month period of, you can see it slowly decaying, boosting, slowly decaying, boosting, then a long decay, boost, et cetera, et cetera. It uses the Soyuz vehicles right now. They have some thrusters on there that are specific to boosting the ISS. So while it is positioned closer to the center of the vehicle, center of gravity, it launches its thrusters and just pushes it up. So how was the ISS built? Well, very carefully initially. and still continuously. But on November 20th, the first one, the Zarya, if you speak Russian, please correct me. I know I'm Zarya, thank you. Launched the original on a proton rocket, and that provided the propulsion, attitude control, communication, and electrical power on the inception of ISS, while we slowly built and sent up the Unity module, and that was shuttled on Endeavour, and it joined with that module, thus creating the first two portions of the ISS. Next, I'll show a little quick time lapse of how that ISS was built from 98. I believe it shows up to about 2022. Yes, they do refuel. So our those cargo resupply missions do send up fuel, oxygen, and water for our crew, and both sides are trained in both languages. Yes, the all American astronauts have to take a course in Russian to become fluent within their time that is part of the astronaut training course, and the Russians have to be fluent in English as well. If in the event that we need to do something on the Russian segment, or the Russians need to do something on the U.S. segment, they can cooperate. It's a weird English-Russian mix language, like Spanglish is English-Spanish, Rushlish, Ing-Shun. It's a weird blend that exists on station. So, and that's where, oh, nope, still going. We are still maintaining it at this time. I do not know that the programs want to continue adding onto it, as the plan is to bring it back down and have a new vehicle up on for low Earth orbit. Currently, the thought is to decommission ISS possibly in 2030 or 2035. But that decision still hasn't been finalized. We're working towards it with Roscosmos and NASA. But until then, we are doing sustaining, still doing science. It is a laboratory, and we will continue doing as such. It's a 20-year-old vehicle that's going 5 miles a second, and it's showing age. We need to be able to put something new up there. It was built in the 90s, but it's technology from the 80s. So every cargo and crew resupply, fuel, and all of those items go up. So approximately every 3 to 4 months, the Russians just had an incident in November, end of November, when they launched their last Soyuz mission, and the launch destroyed their launch pad, and it was their only active one. So they have been fervently working to repair it, and it should be repaired this week, next week. So we're looking to hopefully send up the next Progress mission, which will have more fuel and supplies for the crew and the station. They're planning to deorbit the vehicle and have it burn up into the atmosphere and crash land. I believe it's either the Indian Ocean or Pacific, a very isolated region. It's not necessarily deterioration because of atmosphere. It's also deterioration because of solar radiation and cosmic radiation, which I'll touch upon here in a little bit. A little bit of solar wind. It's also the reason we keep it as a low Earth orbit is so that we can better get up and they can get back down. If we were to go higher, it's more difficult to get higher and out of Earth's gravity to get onto station. So for anybody that really wants to know, here's the configuration as of 2022 of ISS, the exploded view of all the modules and cool little gadgets as an external piece, but you can find that online. So research, over 4,000 pieces of research have happened on ISS in the last 25 years. It provides a unique environment for microgravity, exposure to space, the unique orbit that it inhabits, and hands-on operation by crew members as opposed to being done autonomously. So on the ISS, one thing that we have studied is how does a flame work? How do you burn something on orbit? Or, yeah, in orbit. So the idea of microgravity, a flame on Earth, you expect heat rises. So the flame becomes a point, it's almost like a teardrop. How would that work when there is no gravity and no way for the heat to rise? If there's no heat rising, all the oxygen gets consumed around it. It has no way to get more oxygen. How would that work? So on orbit, this is what a flame looks like. It becomes a sphere. And how do you prolong that sphere so that you can give more fuel, more oxygen for it to breathe? So these are some of the experiments, because if we want to go longer and further to Moon and Mars, back to Moon and Mars, we kind of need to figure this stuff out. So, like I said, without it's a rise, so how the flames become spherical and behave differently. So this is one experiment. In the middle is a fuel ball, and they ignite the outer portion of it. The fascinating portion is that the flame visibly goes out, and it no longer produces heat, but the fuel is still being consumed, and it is known as a cool flame. And it's one of the experiments that they discovered on orbit in one of our laboratories, because it's within a big old container. In case something goes out, it extinguishes immediately, because you don't want to endanger the crew nor the vehicle. So, as well with water, it removes certain tensions and whatnot, and I'm blanking on language right now. Surface tension and capillary movements um, are a bit different with space. They really stick to items. There was an incident where we had a crew member doing an EVA, and there was a small leak that happened in their pack. And the water was slowly coming up the back of the pack and then slowly on their face. And then it covered their eyes. And in a suit, you can't just pull your arm in and just wipe it off. So they couldn't see at all. And they were outside in a giant balloon, as it were. Luckily, they have their crew member that's out with them, because it's always two crew members. They were slowly able to navigate and traverse back. They have two clips, kind of like when you're rock climbing, and you're on one, you move to a different point, you clip off, clip on, et cetera, et cetera. Slowly, that water did infiltrate their nose and mouths, and it could have been a potential drowning on orbit. They were able to figure it out, but if we don't know these in advance, we can't plan for them in the future. So thankfully, we have these experiments, and we know in advance so we don't have these types of emergencies. Here's another example of that flame, of it igniting and how it propagates down, and then how it is extinguishing and how it kind of propagates back up. So continuing on it, exposure to space and unique orbit. 250 miles, kind of far when we're driving, but above Earth, it's a very narrow sphere to see down. High up enough that you can see above clouds most definitely, but not too high that you can't see details. There's plenty of photos of them taking photos of wildfires, hurricanes, other natural disasters, power outages. When they happen in larger countries, you see the entire country just go dark. If you get a chance to see some of these photos taken from the ISS, I highly, highly recommend it. Atmospheric phenomenon, that's a photo a little bit later. As well, we are able to study space radiation. Thankfully, because we live here on Earth and we have our atmosphere, solar radiation, space radiation doesn't get through the atmosphere and affect us here on ground. But if we're sending stuff up to Moon, to Mars, how does a component that's made by General Dynamics or Dell or Apple computers, if we put it on a spaceship, how do we not know that a cosmic solar flare doesn't hit a RAM chip and blow up the computer? And you just left Earth, and you have an 8-month mission to Mars, no computer. So we need to make sure that these common commercial off-the-shelf items can survive within space. So we do send up RAM chips. We send up servers. There's one payload that I'd worked on from a larger corporation. I don't think I'm able to say who it is. Sent up 2 large server farms, plug them in, and they've been running, I think now for 4 years continuously. So each server has 2 in them, and they're constantly communicating with each other. People can sign up for time on these servers, run their experiments, but all the computation is happening on ISS to test how much that computer can withstand being in a solar affecting environment. He would like to. SpaceX would like to. While space is in theory cold, it is hard to get heat off of something to, yes, dissipate and radiate heat correctly, because there is no atmosphere to translate that heat from the physical object off. So it's one of the difficulties that we have on ISS is how do you get rid of heat? So here's a picture of the GEM module. This is supported by JAXA, built by JAXA, as well as the GEM EF, or the external facility, where folks can go and place their external payloads on top, which is always pointed up or to zenith, or down pointing at the Earth for nadir or nadir to view stuff on Earth. If they have experiments that are constantly looking either infrared, looking at forest, tree growth, CO2, or if it's pointing up, it's like a telescope, always looking at the stars and other extra planetary items. So the lovely folks at NASA were able to send me this video of the little short clips and primarily photographs of the best of the science on station for last year. So there is some share agreements between countries with some proprietary stuff. If it's a private corporation that is paying for it, that will stay with the company themselves. But generally speaking, everything that is done through National Lab, it is a U.S. national laboratory, so that is shared amongst, if not all, of the U.S. Scientists. Definitely, you can petition to ask for some of that data, that shared data, but I don't believe that everything that is done up there is shared amongst everyone. I will say the crew stuff is definitely not shared with the rest of the world, specifically crew biodata. The crew has to do health examinations 9 months, 6 months, and 3 months before launch. While they're on orbit, I believe it's about every month or so, is it 2 weeks, that they do a health examination to make sure that everything is going well. And then post return, the 3-month, 9-month, and 12-month mark, they do another bio checkup to make sure everything is fine, thus on return. Things that happen on orbit, they check, there's a device that checks eye pressure on orbit to ensure that the blood pressure isn't affecting their vision as much, because when you're in space, blood isn't always at your feet anymore. It evens out throughout the body, and actually the top part of your body actually swells and increases quite a bit because everything is in equilibrium. So there is quite a bit of swelling in the face and of the eyes. So they have to do measurements constantly to make sure that's not affecting the individual's vision, as well as muscle atrophy and skeletal atrophy. With 0G, they're not walking anymore. They're just kind of pushing off of stuff and floating around. So they do have exercise equipment built into the station that provides resistance. They have to work out, I believe it is 1.5 hours to 2 hours every day to minimize atrophy of the skeleton and muscles. The astronaut chose to self-identify, but they did not choose to identify what they have a vacuum system. They actually do have something for that, yes. It's kind of like a Flowbee, yes. It's hooked up to the vacuum system, and it's just a set of clippers, and they just go and yes, they try to minimize every and all microparticulates that may float around. Yes. It's primarily natural hair color. If you look back to the photos of, funny that you mentioned that, if you look up at the photos for Suni Williams, the astronaut that went on Starliner and came back down on a Crew Dragon, when she launched, her hair was all one color. When she came back down, it was primarily gray. So there is no root touch-ups on orbit. Mm-hmm.
Is the atmosphere and the bombardment of the space station, does that affect that in any way?
As far as we are aware, it does not. They have done some tests earlier to make sure that tattoos, the metals that may exist within tattoo ink, are not affected. And I think enough tests have happened, and it's conclusive that we're safe enough within the vehicle of ISS for that to happen. Yes. I'll take silly. Uh-huh. Yes, there is one other. The Chinese space station, and I cannot remember the name of it. Starts with a T, and I cannot remember the full name. Those members that fly up are known as taikonauts. My original title was a payload interface requirements engineer. So let's say you, as a scientist here on Earth, wanted to see, actually a very apt model, how plants grow on station. So you want to send up some seeds, some growing material, and whatever other items for that material to grow. We help with the interface requirements. It's a really thick book of everything that you need to check off to make sure that it is safe for the crew, safe for the vehicle, and I mean the ISS, safe for the visiting vehicle, safe for the container, that if it's an electrical item, which a plant doesn't need, but if it's an electrical, that it'll work the first time, that the plugs are correct, that the thumb screws are the right thread type. The metal that you're using, the plastic that you're using is correct. If it's metal, that it doesn't have any sharp edges or burrs that the crew may accidentally cut themselves on. That it's clean, it doesn't have any microbes on it, it's free from everything. If it does have a battery or some kind of motor, that it doesn't emit too much of an electrical field or EM field, that might affect other payloads on orbit. Because there's a lot of stuff that's happening on station all at the same time. So there's a thick book. Part of my job and my team for systems engineering and integration, SE&I, is to make sure and interface with the developer, you, to ensure that you check off everything. Once you check off and satisfy everything, we give a green go. Yes, you're good. We send that up. You're able to be packed into the vehicle, launched up, and then you can operate on station. So that's part of what I did. Now, as a lead stage engineer, I work with my team to make sure all the payloads that are going on the visiting vehicle being sent up are good. So I talk with all my team members and maybe you as a payload developer. Hey, where are we at with your testing? Hey, where are we at on this? And I report the status of the entire flight up to NASA management. So, in shorter words. Okay. So, this was from about 4 or 5 years ago. 20 breakthroughs from 20 last years. I'll try to go surface level on description of all 20 of them because I think they're all kind of cool. Disease research, Parkinson's, any kind of Alzheimer's, diabetes, all of that kind of research is also being done on space because of the microgravity environment to see how protein structures are developing, how they're being formed, how they disentangle the cancer cells, how they form in a zero-G environment. Because a lot of times we have gravity, things can identify gravity, we start up. Such as plants, one of the research that we have on station is our tomato sphere and X roots. Plants know how to grow because they send roots down into the ground to gravity. They grow up to the sun. How do you do something like that where there is no gravity? How do you identify what ground is? So it's a combination of hydroponics and intense LEDs and other light sources to give those plants life. We've grown plenty of things on orbit, I believe tomatoes, peppers, potatoes, a number of flowers. And so that's all part of it so that hopefully one day when we go to Mars in that 8-month mission, they can grow their own food on station. We don't have to pack 8 months worth of MREs onto one vehicle. So next one, discovering the cooling flames. I kind of touched upon that earlier. Water purification system. We do send up a lot of water, but a lot of water needs to be recycled. I believe we are able now to recover 93 or 94% of moisture that is expelled from a crew member in whatever manner that may be, through either breathing through our CO2 filters or through the water filtration system through urine and feces. It pulls all that out and recycles it back into the system. So slowly getting maybe not up to 100 because I don't think we ever can, but 94% is pretty amazing nonetheless. Drug development using protein crystals. So on Earth, when we develop a new drug, it's usually start from a crystal. Again, crystal growth being affected by gravity. If you're in a zero-G or micro-G environment, the crystal structure develops slightly different and can be purer on orbit than it can on ground. So some facilities do send up research to start those seed crystals, a batch of maybe 1,000 or so. Then they'll bring them back down and propagate more from what was developed on there to give out to the rest of the world. Yes.
Since we got the speed of the ISS,
Uh-huh.
does it create its own gravity at the backside?
No. No.
You know,
I yes and no. It is to a microscopic level, but because of its orbital period, it is not felt by the crew members because they are going relative at the same speed as it is. If it were to accelerate all of a sudden, the crew member in the inside would float to the back, in theory. But if it was much smaller and you were spinning it, you could create your own gravity. But we can talk about that later. Methods to combat muscle atrophy and bone loss. As I had mentioned, there are workout equipments on ISS that the crew members do have to work out every day to prevent that. I believe it's, I'm misremembering this. It is a large percentage of bone loss that is comparable, I believe, to someone that is 65 or 70. And these astronauts are within 30s and 40s. So they go up normal, if you will, or as their current state, and they come back skeletally as if they had aged about 3 decades. It's very difficult, and I don't think you can fully recover from. Exploring the fifth state of matter. So we know of our four states: solid, liquid, gas, and plasma. There is this fifth state called BEC, Bose-Einstein condensate. Um, and it gets more into the quantum realm of matter, where we lower the environment down to a billionth of a degree above absolute zero. So that's negative 273 point something Celsius. So we get it down to a billionth degree above that and see how the atoms are interacting. Einstein and Bose, many years ago, theorized this, and it was actually observed back in the 90s here on Earth, and I believe in the late or early 2020s, we actually did it in space. And because of microgravity, we could use the lasers to hold it in place. So the idea of an atom is really hard to identify because all the electrons are going everywhere. It's more of a cloud. You can't really ever identify a single atom. We can identify them if they're in a bunch of groups. But the idea of a BEC is that they're getting so cold and so low energy that the electrons are slowing down to almost perceivable points. And they're condensing to a group. So it's no longer just a single atom, but a collection. It's a blob. So we can better identify those items. This is a little beyond my scope because I'm not really into quantum physics and everything else. So if you'd like to learn more, Google is your friend. Understanding how our bodies change in microgravity. There was a twin study done a number of years ago with Scott Kelly and Mark Kelly, the twins, both astronauts. One went up, one stayed down. I did baselines on their health, everything, and since they were twins, it worked out great because they were almost identical, DNA-wise, and etc. One was up for, I believe, about 9 to 11 months. He came back. They saw what the differences were. How much did one age versus the other? How did solar radiation and space radiation affect one versus the other, et cetera, et cetera. So there was a wonderful twin study done on that, and they always examine every person that goes up. Almost every astronaut is trained in phlebotomy because they have to do blood draws of each other to collect blood samples and they send them back down to make sure that the crew is healthy, that nothing crazy is growing or happening to them while on orbit. So that is something that we do all the time. Testing tissue chips. We send up human growth tissues to see how they are affected on ISS. Sometimes we might send them out to the outside and see how the bombardment, bring it back in. Okay, we'll send it back down, further research. So that's another thing that is being done. Low Earth orbit economy. So one of the things that we send out of ISS and we do in ISS are something called cube labs. Many universities are doing these 10 by 10 by 10 little cube satellites. They build them, they do whatever science they want. They send them over, it goes up, and then gets punched out of ISS, and then they go around the Earth for about a year before they slowly descend and burn up. Embry-Riddle has done 2 cube satellites. I was a part of the first one many moons ago, no pun intended. And we were observing the effects of solar radiation on commercially available RAM and something else. So essentially, we were just buying a whole bunch of RAM chips, putting it on a little motherboard, putting it in the cube that it could transmit back and forth with ground stations. It would go up, pop out, little solar arrays would pop up, the antenna would pop up, and it would go around. And the idea is that the computer would just write ones and zeros, ones and zeros, ones and zeros all the time. And then we would check in every month, or not every month, about every 2 or 3 days or so. Hey, what's your status? And we'd read the RAM. Is it still showing all ones, all zeros? Or is it going all zeros except 1, 0, 0, 0? And then we'd see what's happening, what are the effects, and long-term exposure without a shield or something more advanced to shield that item. So a lot of universities are doing it. It's an affordable way for students to get research with whatever their degree may be. Could be something science, it could not. I've seen a lot of art installations go up as well. Growing food, as I had mentioned, the plant growth. They have grown some tomatoes and peppers, potatoes. There was a funny story a number of years ago that from X Roots, they were growing some tomatoes in that facility. And the crew member had accounted and written down, yes, we'll say 9 tomatoes that they had collected and they put in the bag. They went over, and then when they went over, they counted again in the bag before stowing it, and there were only 8. And they looked everywhere, and they couldn't find the 9th tomato. Everyone assumed that the crew just snuck it. They lied. They ate it on board, because how often do you get fresh fruit while you're on an orbiting station? You know, you're eating a whole bunch of MREs and other food provided items. It's nice to have something fresh. So the crew member was not officially blamed, but it was kind of an open secret that, yeah, that crew member ate it. I believe late last year, that tomato was found. It was all shriveled up, not molded whatsoever, but they did find the tomato, and the crew member has been exonerated of all accusations. It was in a very dry environment. It's not very humid on orbit. Deployment of CubeSats. I had mentioned those CubeSats. That's part of that low Earth economy. Monitoring planet from space. One of those pictures showed looked like a lightning bolt shooting out of the top of cloud. And that came out in 2025. It had been theorized that these kind of lightnings or events, electrical events, happen, but it's very difficult for us to see them on Earth because clouds, and see them from satellites because they're generally pointed so far away that you can't see individual strikes. So while it was a perfect, again, mind the pun, a perfect storm, as station was orbiting, they were taking photos, and this one lightning event happened upwards. It's a beautiful shot. I would definitely recommend checking it out. 100 billion cosmic particles. We're getting bombarded all the time. There are plates that go up of titanium and higher metals that help capture some of these cosmic particles. They're contained. We bring them back down, and we observe them here on the ground to see what is really passing by our Earth and our local neighborhood. Better understanding of pulsars and black holes. Here on the ground, we have the atmosphere to blame for everything looking out. It creates a bit of atmospheric lensing for telescopes. We can't truly see what is out there unless we are out there ourselves. So on station are a number of instruments that are pointed up and away from Earth, always looking at the sun, the stars, and the vastness of space. For black holes, there was an experiment a number of years ago, trying to detect the gravitational waves. So that's part of the black holes. When you don't have the lens of the atmosphere looking through, and you're looking out to seeing something that doesn't emit anything, it's much easier to see what that infrared and X-ray and gamma radiation that's being expelled off of it. Student access. You don't have to do a cube lab to get access up there. One of our payloads that we have up there is ISS ham radio. We have a ham radio on station. If you're a ham radio operator, you can get that code and try to call in and get them on the frequency. Every country has a different code to get to the same station on ISS. So if you are a ham radio operator, please feel free. Capability of identifying unknown microbes. We have found that there is a growth of microorganisms on the exterior of ISS. How they came into being, what they may have come upon, it may have been on a visiting vehicle that went up, docked, and a particle just flew off, fell, and somehow it is surviving. So we're taking little Q-tips and kind of scraping it off, putting it into a bag, into another bag, into a metal block, then sending it back down and trying to identify how is this stuff growing, how can we better prepare ourselves or future things to survive space. Colloid research. So the idea of mixing particles within a solution is something being able to dissolve, or do you still have particulates in a solution? Colgate and a number of other partners have done some research on ISS on how to better integrate chemicals into the solution medium or liquid medium. Again, gravity effects. So when you're mixing something into, let's say, something like toothpaste, are all those particulates dispersing evenly? When you send it up to space and you mix, that mix is very different than what you would see down here. So these companies are sending up investigations and research up there to find out better ways of how can we evenly distribute either medicine, cleaning agents, items that could dissolve in water for medicine more easily and readily back on Earth as we could on station. Fluid physics research. This one is rather interesting. Of course, with microgravity, you have water, other liquids that are just floating about. One of the issues and things that we have been working on, I say we as NASA collectively, not just myself, is when we are launching to Mars or to distant planets or whatever it may be, how do you keep fluids in the back of a tank? So let's use for an example a gas tank. When you're floating in space and you get to that 0G microgravity, that fluid is no longer in the back of the tank with a fluid pump. It's now floating within the tank. So how do you get that fluid line back down? Theory, okay, you put a balloon on this side and you slowly inflate that balloon, keep all that liquid on the other side. But now you have some kind of gas weight added onto your vehicle just for that purpose that has no other purpose. So you want to try to figure out how best to utilize what we have, minimizing weight, to put on food, water for the crew, etc. And that's why we're trying to find and do research on Moon and Mars to find if we have water there, we can get the hydrogen from water and use that as a fuel source to launch back up or launch further to Mars. So that fluid physics research is still ongoing, and you can theorize it all day long, but it's awesome to see it actually happen floating around. 3D printing. I know a few folks have gotten into the 3D printing realm, but the idea of 3D printers, when you extrude filament on, it lays down, mainly because of gravity, mainly because it's been deposited onto the surface below it. But when you're starting to do 3D printing in space, again, because there's no gravity or you have microgravity, the filament that is being extruded doesn't settle and you don't get that weird blob, but it maintains the shape as it was extruded out. So in some cases, you get stronger materials. There was an incident where the crew needed a wrench. They 3D printed the wrench on orbit and they were able to use it. So things like that, where if in the future we have some kind of space station or colony on Mars, we can 3D print whatever tools and items we need and would need on there. And then 20, responding to natural disasters. Because it is orbiting the Earth every 20 minutes and slowly going around, we can get a 250-mile view of what's going on, sending those photos down. If there's a IR tracker, we can see the heat dissipation of the infrared for like the wildfires in California. They can get an IR map of what's happening. So those are 20 breakthroughs over the last 20 years. So if you wanted to track the station yourself, I see I have about 10 minutes. I'm going to try to jump through this. There is something called Spot the Station. You can download it on iOS and Android devices. You can go onto a website called Spot the Station, and it'll actually show you the current location of ISS, where it was an hour and a half ago, where it will be an hour and a half from now. And it's constantly updated. So this is a real-time map of ISS. On your phone, it uses your geolocation and the gyroscope in it. So you can actually point and look to see where it is in relation to yourself. You can set up notifications to let you know an hour or 2 hours beforehand when it will be in view of you. And you can be out there at early in the morning or late. It'll tell you your degree and your azimuth. You just point the phone, see where it is. If it's at night, you could probably just see the white little dot coming across the sky. Or you can take a look around for yourself. This is another cool little thing that exists on the internet. Google Maps has partnered with ISS. And you can take a look at this and go and look around ISS yourself if it'll buffer correct. There we go. And then there's little buttons you can highlight, click, and it gives you a little blurb of what. So yeah, you can go around, see how cluttered and chaos all of the ISS is, all the wires. And these are all experiments. These are the lockers. There's no real up, down. It's kind of like a ship at sea. You have forward, aft, port, starboard, zenith, and nadir to look around and to dictate where stuff is. So at your own leisure, you can punch in ISS Google Maps and it'll take you to one of these pages and you can view around yourself. So real quick, future of space, Artemis, NASA program to get us back to the moon. So hopefully keep, in theory, boots on ground for the foreseeable future. And if you didn't know, Artemis is the Greek goddess of the hunt, wilderness, wild animals, the moon, and chastity, and the twin sister of Apollo, hence the name for the Apollo missions, now the Artemis missions. Gateway is the other future. As you mentioned, we have a station above Earth. Are we doing something about moon? Gateway is our program for our no, that's not correct. A station around the moon, because it does a different trajectory than before. Artemis 2 is currently planned for no earlier than April of 2026. So early April 2026 is when they're planning Artemis 2. It had to be rolled back because there was a fuel leak. They have since found and isolated and fixed that fuel leak, and it's now being sent back out. It's a 10-day mission. They will go around the Earth a few times and then boost on the backside, giving them enough speed to get out of Earth, and then figure eight around the moon. The gravity of the moon will bring them back and slingshot them back to the Earth. They will slow down and then land in the Pacific Ocean. Is the plan. So this is kind of what the operations look like. Again, all of these are available online. Since I can't use any private information, this is all publicly available. And this is the schedule that we were kind of looking at. Everything in green was a launch opportunity. So the next one will be April 1st, then 3rd, 4th, 5th, 6th, and then April 30th. Beyond that, we'll have to see what the schedule would look like later on, because trying to pinpoint a good time to get to the moon is kind of difficult. So Artemis 3, that has now become an uncrewed mission just to do demonstration around low Earth orbit. Artemis 4 is now when we're planning on putting actual boots on ground, bringing humankind back to the moon, and working on that lander that both SpaceX and Northrop Grumman are working on. And then Artemis 5 and beyond, they want to have a better cadence of let's launch every year, because once every 3 years is not economically good. Let's get back to the days of Apollo, back to the days of shuttle, where we were launching every few months. On one rare occasion, it was a 3-week period that we launched one shuttle, then the next one. But time and patience for the future. Gateway will deploy in a near rectilinear halo orbit. What the heck is that? I never heard about it until I started working and helping out with Gateway and Artemis. It is a very eccentric orbit. If the moon is here, it's going real close to the moon, and then it goes real far down, then real close. We're not going around, because if we went around this way, we would lose communications with the Earth for a period of time. So doing this kind of orbit that's near rectilinear halo keeps us in communication with the Earth at all times. It's about a 7-day period for it to orbit around in that manner. So this is what it looks like in simulation. So here's the Earth in the middle. The green is the moon, and then the pink is halo. Here it is as viewed from Earth. So we always see halo orbiting up and around the lunar surface. And if Earth was on the left direction, this is how it would look from the side profile. Just that up, down, you kind of see a little bit of a curvature happening. The first 2 modules that are planned on being launched are the PPE and Halo. Halo standing for Habitation and Logistics Outpost. And that is where the crew will live, eat, sleep, do the small bit of science that they can. And like ISS, other rockets will send stuff up and will slowly build out Gateway as a whole. And the idea of Gateway is that it'll go to Mars. Hence you see Mars kind of off in the background in that logo. So here's a SpaceX is. SpaceX is. I will always distinguish Elon from SpaceX. So, scales. It's hard to imagine what the scale of the Earth, what the scale of the moon, all of these items, we live on it every day. We've been here since we were born. We will go down into the Earth once we pass. So, I like to think, how can we do a relation? So, there is a relation that we can figure out here on Earth, and that scale is 53,541,091.43 to 1. So, how can we compare this? Using that scale, it comes out to 9.38 inches. What do we have that is 9.38 inches to be comparable to this? Moving down, moon diameter at that same scale is 2.5 inches, and the sun, 85.2 feet, if we were to scale down to something that's a little bit more visible. So, Earth-wise at 9.38 inches is a basketball. So, I have a basketball. Please catch that. So what would be about 2.5 inches? In relation, you can keep that over there. The Earth, okay, that's fine. That would be the size of the Earth, and this would be the size of the moon. So in relation to all of this, how big would be the sun? 85 feet is an 8-story building. So something to think about. Now, distances. If we're looking at Earth to Moon, Earth to Sun, how far away are we talking about? Proxima Centauri, SAR, many, another system away. So how far away do we think the basketball is from the tennis ball in scale relation of 238,855 miles? So here's your guesses. A, 5 feet, B, 7.67 feet, C, 17.86 feet, D, 23.5 feet, E, 33.33 feet, or none of the above, it's so much further away, or the moon isn't real. What are you talking about? 12 feet? E, 17, 23.5 feet. So if we hold that there, 23.5 feet is the Earth to the moon in scale relation. So when you look up at night and you see the moon, this is how far it is if you were on that basketball. If you were one of those little knobs. So what is that in relation? Because again, it's hard to conceptualize what is that in relation to where we are. So the white dot is the lodge. It would be on the backside of Yavapai campus and the backside of the VA from the lodge. If the lodge were the sun, Earth would be on the backside of the VA and the backside of Yavapai College. And again, at this scale, so that basketball is orbiting this building that far away. And then Proxima Centauri, closest star. How far away would that be? Well, I'm not going to do anything crazy on this one. Scale down, it's that many thousand miles. How many miles is that? We don't know. Twice the distance from this to the moon. So it's going to the moon and back is a scale from this building being our star to the next star. And even did the ISS width in scale version. That is 0.00008 inches. So if you took a human hair and cut it up 88 times, that is the width of ISS in comparison to that basket. Yes, I did. The other portion of what you were wondering what low Earth orbit is, ISS orbit height at scale, 7.4 millimeters. And that is part of the plan with Gateway getting forward to the Mars missions, is the idea of sending up fuel depots to that lunar orbit so that we can launch from Earth, get to the moon, refuel, because launching fuel is most of the problem. About 98% of the weight of a launching rocket is fuel, just to get that little tiny piece, which is the crew capsule, up to the moon and back. During the Apollo missions, we brought a bunch of that regolith back. And at the time, the NASA engineers knew that they did not have the science and technology at the time best to analyze it. So there are several tens of kilos that are still at JSC unopened, so they can analyze, and they have been looking more at it to see if we can make lunar concrete, lunar whatever. What are the compounds within there? Can we pull out metals? Can we pull this out to help make, hopefully, a habit in the future? Maybe it's just a simple mud, brick, adobo kind of thing house, or similar to in igloo, some kind of structure made from the regolith of the moon so that we can habitate longer, but also the idea of how do you keep air inside, how do you keep solar radiation out, because the moon doesn't have any atmosphere to protect from solar radiation. There's a lot of other factors, but there are folks that are definitely thinking about that are way above my pay scale. NASA and the US would like to keep a low Earth orbit presence and not give up that presence in the foreseeable future. We have been working with other companies and organizations to build a privatized, mainly US-based laboratory to replace the ISS. That has not come to full fruition. There was a company that said that they were going to build a station. And then they said maybe half a station. Now they're saying maybe just a module. So it's working with Axiom, Boeing, Northrop Grumman. I think Virgin may have pulled out. Blue Origin is in the mix. So more privatized as opposed to a government or an agency, but NASA still being within it. NASA is starting to look at potentially using artificial intelligence in helping with data analysis, but not in creation thereof. Personally, my own, I do not speak for the company, nor NASA, nor anybody else. I do not like the use of AI. I graduated with computer science with a focus of global security and intelligence studies. The way AI is going right now, as unregulated as it is very concerning. The amount of information we are pouring into these systems, unregulated, is frightening and should be of big concern. Not necessarily for a Terminator style Skynet takeover, but the information that is being put in there that is your own, that other bad actors are getting into. You're dumping information in. You're having ChatGPT. You're discussing things. You may not think you're discussing any prevalent plans, but like, hey, how much does this ring so-and-so cost? What's the ring for? What are your future plans with the ring? Are you planning on making a big purchase? That means you have a lot of money on your pocket. That means I can hit you from another source. Your logins for it. There's a breach to Claude, Meta, whatever it may be. All of that information, most of the time, that password that's used for that system is another password that you have for another system. I do not like the current use of AI as a data analytic and helping find items that humans cannot for a while. Great. There was a study done a number of years ago where somebody wanted to find irregularities of dough in their bread making procedure. So they uploaded all of these images of their dough making process. They were able to find irregularities. Then it turns out that cancer has the same kind of appearance. And so now we can identify cancer well sooner than doctors could have beforehand by spitting these images from MRIs and CT scans into an AI image, because it is able to process and detect things that we as humans currently cannot based off of our own eyes. Those are the opinions of myself, not of NASA, Boeing, S&K, or anyone else. So there is a distinction that we in the science community have, that we separate ourselves from politics. I understand. But the agreements that we have, that NASA has with Roscosmos, along with ESA and everything else, is that all of that stays within the ISS environment. If you look at the Chinese space station, it is almost a near copy of ISS. But they just launched that 2 years ago? Yeah, but they just launched that 2 years ago. This thing has been flying since '98. And it is '80s technology.
So they've got a 1980s.
They have just copied 1980s tech, maybe slapped on a few cool metal things on it, but if we can get a good, stable quantum computer in actual existence, it will be revolutionary. We do not have that technology yet. We're getting close, but we're not there. It's probably quantum-like, or they are using quantum and the name nomenclature, but having quantum computing, an actual computer that instead of 1 and 0, it is doing both at the same time, it is all possibilities all at once, does not exist. If we can figure out a way to get everyone talking the same way, maybe. But right now, binary is a pretty good language. It's been working for the last, 70, 80 years? Actually older. Binary is a much older technology than that. Until everyone can get on the same page and have a unified coding system and structure a language at the root level, we'll see. The SLS is the largest rocket that we have launched from the government. Starship, when it is ready and fully complete, will take that at that point, and that's SpaceX. But right now, SLS is the largest. Yes. Yep. Early April. So I would keep an eye out for that. NASA TV on YouTube does a live feed. They will start 12 hours beforehand when they start fueling that sucker up, because that hose is like about this big, and it connects to the side of the rocket, and it's just pumping tons and tons of liquid oxygen and something else to fuel up those tanks. So it takes quite a while to fuel that rocket. When we load the people on, get everyone away, pull the tower. I have encountered a few while being on site. Yes. I shared an elevator one time with them. They had just come down 3 weeks beforehand. They had just gotten out of quarantine. I get in, and then she walks in next to me, and I'm like, inside, I'm going, ah! Outside, ma'am, good morning. Gentlemen, brothers, thank you all.